14 degrades over time, and the amount of carbon 14 left in the item tells you how old the item is. Now, an item is 2,000 years old. Use the formula to find the proportion of carbon 14 in this item. Okay, no bother. The Q value, which so actually, as it turns out, if I just threw this right into the calculator straight away, like I'm literally talking straight in. So you go for your E function, e to the power of minus 0.693. I'm going to go for x. I'm going to press the fraction button over 5730. I'm going to start at 0. I'm going to end at, for argument's sake, 4,000. I'm going to go steps to 200. Now look what happens. When the item isn't old, it's basically right here, right now. It's brand new. It has 100% of its carbon 14 still there. When an item becomes 200 years old, it only has 97.6% of its carbon 14 left. Does that make sense? We scroll all the way down to 2000, and when you're 2,000 years old, you have 78.5% of your carbon 14 left. Is that alright? So, for question 1, it's really easy. All you need to do is sub in your T value. And you lob all that into the calculator. Like so. And the worst thing is, we already know the answer. 0.785. And you're good to go. Everybody cool with that? Now, the next question is slightly different. Find the proportion of carbon 14 in an item found in Lochburr was this much, 0.3402. Estimate its age correct to 2 significant figures. Alright, for those of you that don't remember what significant figures are, I'll give you a brief history. This is one significant figure. Oh, sorry. This is one significant figure. Yeah? What's this one? 4 significant figures. This one, however, is 2 significant figures. If the zeros are at the end, they're not significant. Alright, let's try this one out. How many significant figures are here? 3. What happens if I change that to a 1? 6 significant figures. Go with that? Let's do decimals now. Decimals are different. Alright, significant figures for decimals. Alright, let's start off. Anybody got an answer here? 1 significant figure. Anybody got an answer this time? 2 significant figures. Now, how many significant figures now? 5. The zeros are sandwiched in between. So it's 5. What about this answer? 4 significant figures. We cool? Have we mastered significant figures for the rest of our life? Hopefully. Now, here's what we're going to do. We're going to take this number here, which is 0.3402, and we're going to bring it to the left. And we're going to use this formula here. So we're going to get 0.03, sorry, what's this? 3402? Memory of a goldfish. There we go. Right, that's the Q value. So what's the equation? E to the power of minus 6993t over 5730. What's the goal of the question? Find the T value. We're looking for the T value. Okay? Any ideas how to get the T value? Any log of your choice. Any log you want. How many people will choose ln? If you're in an exam right now, would you choose ln? A lot of you wouldn't. Alright? So I could do it with ln, but I'm not going to. I'm just going to see if I can do it without ln for a minute. Okay? So most of you will just pick log base 10, would you? I reckon most of you will go for log base 10. Okay. What happens to the power? What happens to it? Goes to the front, doesn't it? So this whole thing goes to the front. And oddly enough, see my calculator, we can get a rough idea where it is. 0.34, how old do you think that is? Let's go longer. Let's start at 4,000 and at 8,000. And keep going until you see 0.34. Keep going. And we know roughly where we're going to expect our answer. It's going to be over 8,000 years old. Would you agree with that? I think we're very close to getting it now. Start at 8,000, end at 9,000. Do step of 100. And lo and behold, I'm pretty sure I'll get a pretty accurate number here. There you go. Around 8,900 years old. If I don't get an answer like that, I know what I've done is complete crap, basically. Do you get what I'm saying? So I've used this technique to check my answer before I even get it. Now I'm going to go about getting it. Okay. Log E. Everybody cool with that? And then on the other side, it's log 0.3402. Alright, next thing. What goes where? Where does the 5,370 go? It's division on the right, which means it will be multiplication on the left. Okay. The 0.6 minus 0.693 is multiplication on the right with the min. Huh? Division on the left, anybody? Okay. The log E is what on the right? Oh, sorry, no T. The log E is what on the right? The log E is multiplication. So what does that make it on the left? Division. Now, and that's T on its own. All going well. We're going to number crunch this and get 8,900, somewhere in that region. I suggest you practice now. Surprised how many times I see mistakes here. Let's try it out. What? 5,730 log 0.3402 all divided by 0.693 log, now E we're going to go for, so shift E. You could potentially get rid of the power. No, you can't get rid of the power. So you have to do E to the power of 1. Is that okay, everybody? Anybody get an answer? Huh? Is that what you're expecting? Exactly. 8,915. So what you've shown there is complete control over the question. You knew what answer you were getting before you even did it. So that means there should be no surprises. Yeah. We cool? Alright. Now, I picked some of these ones. Alright, let's do this one. A bit of geometry revision for you. I remember how to do this. Do a rough diagram here. 2 trees located here. 2 cross tree up. 5, 7 would be yes. 5, 7 would be somewhere up here. 5 across, 7 up. It could be somewhere like this, right? So, what do we know about the horizontal gap and the vertical gap to get from there to there? How many across? 3 across, and how many up? Is it 3 across, 4 up? Alright. And somewhere in between these two lines, what is there going to be? There's going to be a green point in the middle. And the green point has to divide it in 3/4 is to 1/4. Where did I get 3/4 is to 1/4? Add that together and what you get? 3/4 and 1/4. Okay, so I'm going to ask you guys now is, what is 3/4 of 3? 3/4 of 3. What do you reckon? What? 2.25? Means you move 2.25 to the right. What's 3/4 of 4? What's it? 3 upwards, isn't it? So what do you have to add? So you get the 0.23, and what do you add onto it? You add on 2.25, and what you get? 5.25. And what happens when you add on 3 plus 3? 6. Sorry, 4.25 and 6. Do you think that point would be closer to 5.7 than it is to 2.3? Does everybody believe that point would be closer to 5.7 than it is to 2.3? It is. And it does exactly what it was meant to do. That's 4.25 and 6. We good? Alrighty. Keep going. This one. Bit more difficult. Haven't really got a clue where they are on the x-axis. Or xy axis. A could be here. B could be anywhere, couldn't it? B is any x value and the number minus 5. Do you get what I'm saying? We know it could be anywhere on this line here. Anywhere on the minus 5 line. We don't really know where it is. Okay? Now what else is there? We know the other part is minus 6y. So P would be somewhere along here. And Q would be, A, P, and B. Something like this. The honest truth is I am pretty sure. I haven't got enough information to draw it, do I? No, that's the answer, right? What's the deal? This is 1/4 of the length, and this one will be 3/4 of the length. How do I know that? Yeah, the ratio. The blue one is 1/4 of the total length, and the green line will be 3/4 of the length. Okay, that's what I got from the ratio. 1:3. Now here's what we gotta do. So 1/4, 3/4. Okay, let's figure this out. Alright, let's start putting in values for A and P and B. Alright, what's A again? A is minus 10, 7, no bother. Okay. P is minus 6, what? What? Y. And then B is X minus 5. Alright, here's what I reckon. Charlie, what's the gap from minus 10 to minus 6? Plus 4. You went plus 4 to X, would you agree with that? So you went across 4. That's only 1/4 of the entire distance. So what would be the whole distance across then? 1/4 is 4. 4/4 would be 16. What's 16 added on to minus 10? 16 added on to minus 10? 6. That would make this point 6 minus 5. Okay? Next thing. What's the gap between 7 and minus 5? Plus 7 and minus 5. 12 down, isn't it? Minus 12. Now what's 1/4 of 12? 3. 7 take away 3. Anybody? 7 take away 3? 4. And there you go. There's your graph done. Okay with you guys? Alright. So that's it. All right. Now, it's I think I got some more stuff here. Oh, awesome. Not awesome. Grim. Grim. Alright. Here we have a triangle. And find the equation of the line through B, which is perpendicular to AC. Go on, you guys try it first and I'll follow you in. Alrighty. Alright guys, get the slope of AC would be your first bet. So slope formula of y2 minus y1 over x2 minus x1. Please do not get the letters mixed up early in your exam, because then it's just a complete minefield to give you any marks whatsoever. Double check, take your time. Do not rush it. The other thing you might want to know is you're expecting a negative slope, aren't you? Why are you expecting a negative slope? You're going downhill. If you're playing Super Mario, you'd be going downhill right now, okay? If you don't get a negative slope, something's gone wrong. Alright, Killian, what you got?
Minus 2 over 3.
Now, even better. Minus 2 over 3. Look, it's very obvious. 3 across and 2 down. 3 across, 2 down. 3 across, 2 down. It's perfect. Alright. Next thing. What we're looking for is, I want a line that's perpendicular to this, but goes through B. Now, you're not drawing it in per se, but it's something like this. You want it to go through B, but it's perpendicular to AC. So what's the perpendicular slope? Yeah, perpendicular slope is 3 over 2. Now you're going to use y minus y1 equals m into x minus x1. What point does it guaranteed go through daily? What point does it go through? It goes through 5, 3. Okay, B, which is point B. So y minus 3 equals 3 over 2 into what? X minus 5. Multiply that all out, you get 2y minus 6 equals 3x minus 15. Move it all over one side, minus 3x plus 2y. What's that going to be? Plus 9 equals 0. Everybody cool with that? Use your answer to part A above to find the coordinates of the orthocenter. What on God's green earth is an orthocenter? Oh, this thing. It's where you get the perpendicular slope. Example: if I get the slope of the green line, I use the point that's not on that line, and then I get the perpendicular line that goes through that point. If I use the slope of the purple line, I therefore create a blue line that goes through the other point and hits it perpendicularly. Where the 2 points intersect, example, a simultaneous equation, where the 2 lines hit each other will be my orthocenter. We cool with that? Alright, so we have one of the lines already, which is, we have this one already. So let's all choose the same one. Lads, which one do you want to choose? BC or AB? It's all good. Which one do you want to go for? Go for AB. Right, do the exact same routine for AB right now. Get the slope of AB. Get the perpendicular slope, and then thread it through C. Do exactly what you did for question A in question B, just using a different line. If you just look up the start of that chapter, you'll see the different descriptions. Okay. So we're going to get the slope of AB, and then we're going to thread it through C perpendicular. Let's do it. So slope of AB, that's x1, y1, that's x2, y2. 3 minus 2 divided by 5 minus 6. 5 over minus 1 is minus 5. Perpendicular slope is 1/5. Hence y take away y1 equals m into x minus x1. And what we get is Has to go through C. So C is x1, y1. Remember, the point you're looking for goes through C. That's actually really awkward looking. So that's your line there. It has to go through C perpendicular. It's going to be outside the circle. It's interesting. Hard to visualize. So that's going to be up there. And then I'm going to hit. The intersection is going to be miles out, isn't it, lads? Lads, the intersection is actually outside the triangle itself. What's this, ortho center? Alright, so if you're wondering about this, just give me 1 second. Here's why. Ortho center, we have an obtuse triangle. When you make the triangle obtuse, what happens to the ortho center? Actually goes outside the actual triangle, doesn't it? So some of you have already got the answer of 7, 6. That's why we're finding it hard to visualize. It's where these two lines hit. Oddly enough, it's 7, 6. So we actually knew the answer for once. So it just hits out here. I know my drawing's a bit off. So actually they both hit up here. So that's why you're finding it hard to visualize what you're actually doing. Okay. So what's the equation up the other line then? We're nearly here now. We're going to do y goes through c. So what's it? Y minus 4 equals a fifth into. What's it? X plus 3. We got 5y minus 20 equals x plus 3. Move it all over one side. You get minus x plus 5y minus 23 equals 0. We now have the equations of both lines here. This one, yeah, and this one, yeah. Now, I'm going to write this as 3x plus 2y. Sorry, 3x minus 2y equals 9. And then I'm going to rewrite this one as minus x plus 5y equals 23. I'm going to multiply this by 3. I'm going to get minus 3x minus 15y. What did I say I multiplied that by? 3. That would make that 39, wouldn't it? Make this 13y. I completely messed this up a second ago.
69.
Yes, it is. Then y equals 6. Now, guys, we put in y equals 6, so it's going to be minus x plus 30 equals 23. And then we all figure out that x equals 7. And as the lad said, there's an intersection of 7, 6. Okay, we cool with that? We were expecting the ortho center to be outside, because as I showed you on this website here, if it's obtuse triangle, the ortho center is outside, and it's acute angle, it's on the inside. Okay, so we're happy with that. Now let's move on. All right, guys. The centroid is a different fish. The centroid always has to be in the middle. Do you get that? How do you get the centroid out of interest? What's the method for getting the centroid? It's any point linked to the midpoint of the next line or the line opposite. You get what I'm saying? D is the midpoint of AB, D linked to C. E is the midpoint of BC, E is linked to A. So does everybody get that's how the centroid works? And there's a general formula for the centroid, isn't there? And that's what you have used. But please don't forget where the centroid actually comes from. Don't forget those diagrams. Same for the ortho center as well. Is that right? Okay. I think I had something else. Where is it? Which one? Centroid. But check for it now, actually. I don't think it might be. Can anybody see anything for the centroid? Alright.